Now here we'll discuss on the stress-strain relationship for a material. And this is shown in this diagram where the horizontal axis is the strain axis, that is written as E, and the vertical axis is the stress, denoted as sigma. Now when some load is applied on a material, the body will start to deform, and this deform is shown here in the horizontal axis, the strain, which means deformation, and the vertical axis, if you see, this shows the stress, which is the resistance. The word stress, it means resistance. The body doesn't want to change its shape, so it is resisting the force here that is shown over here. So we can get some relationship between the stress and strain, which is shown here in the form of, first we have a straight line here. Let me mark the points first. This is O, this is A, this point B E, this is Y1, this is Y2, here we have U, and this point is F. So these points have its significance. So I'll explain you the phenomena that is happening over this diagram. So now from O to A, if you see, we have a straight line here, inclined line, which means that there is proportionality between stress and strain here. Now you take any point between O and A, if you see the slope, that is, if you take the stress-strain ratio here up to the point A, will have the same ratio, which means the stress is directly proportional to the strain here, and this is what the Hooke's law states. So this is the Hooke's law, stress is directly proportional to the strain, but this will be valid till the point A, and the point A is called as the proportionality limit. Proportionality limit. Beyond this, it will not obey the Hooke's law, that is, we won't get the proportionality anymore. From A to E, if you see, this point E has a lot of significance here. E is called as the elastic limit, and it is the point up to which the material will exhibit elasticity. Up to here, the material will be exhibiting elasticity, and beyond this, it will be exhibiting plasticity. Now, what is elasticity? This is the state of the material, this is the shape of the material or deformation up to which the body can regain its shape. Up to this, the body can regain. Up to this, whatever strain we are getting here, once the load is removed from the body can come back to its original shape till the point E. Beyond E, we'll have plasticity. And plasticity is the state of the material where the body will not regain its shape. So whatever deformation happens after this, so the body will not regain its shape back on the removal of the load here. So now from E, it is reaching the point Y1, where Y1 is the upper yield point. Upper yield point. So here, if you see, in this curve, if you see the stress and the strain, if you see here, so there is a greater strain here. The deformation is more here, whereas the stress is less, which means that the body is easily deforming here with very less resistance till it reaches the point Y1. So here this is called the yield point, because after the point E, the body has started to yield, that is, it will not regain its shape. Then it reaches Y1. Then from Y1 to Y2, if you see, it reaches the point Y2. Here, this portion, this is the strain we are getting, and for this particular strain, the stress, the resistance is decreasing here. The resistance is decreasing, which means that the body here does not offer much stress. Without much stress, the body is reaching the point Y2, the lower yield point. Y2 refers to lower yield point. Now, what is happening beyond Y2? Beyond Y2, you can see that there is increase in the stress again. The stress is increasing. As the deformation is happening, as the load is applied, the deformation is happening, but this deformation is not happening so easily. Rather, the body is exhibiting more stress here, and the stress is reaching its maximum value here. This maximum value of stress is called as the, so this is the maximum value of stress, which is the ultimate stress. This is called as the ultimate stress. Beyond this, the body cannot exhibit any more stress. This is the highest value of stress that the body can exhibit. And then after this, you can see, after the ultimate stress, further increase in the load, the deformation will happen, but there is reduction in the stress. The stress will reduce now, will decrease, and it will reach the point F, where the point F is called as the fracture point. Fracture point. At the point of fracture, the body will break into two pieces. Now from Y2 to U, if you see, this phenomena is called as strain hardening. Strain hardening. And this implies that the strain, the deformation that is happening is not happening so easily, because here if you see, the stress is very high and even it reaches the maximum value of stress. So the body is not letting the deformation to happen so easily because of exhibiting more resistance here. So this is the strain hardening. Then from after reaching the ultimate stress, from U to F, the body is, if you see here, the body is not showing much resistance. The resistance is decreasing again here. This is decreasing till it reaches the point F. So this is called as necking. Now take one ductile material which has reached the ultimate stress. So after it reaches the ultimate stress, further increase in the load will result in reduction in the diameter of this material, and it will go on reducing as the load increases, and finally it will break into two pieces. We'll get two pieces here. So this phenomena is called as necking, and the point where it breaks into two pieces is called as the fracture point. Now talking about the Hooke's law, which states that stress is directly proportional to the strain, and here stress will be equal to capital E, that is the proportionality constant, into small e, that is the strain, where the proportionality constant is called as the Young's modulus. Young's modulus. Now what is the unit for the Young's modulus? We know that stress is, the unit for stress is Newton per mm square, or also I can say megapascal. This is the unit for this. So now, strain unit, it has no unit. So I can write the unit for Young's modulus will be the unit for stress itself, that is Newton per mm square, or also I can take it as megapascal.